Now, important results that we need to learn that we should be able to do very quickly. Anytime you have the log, no matter what the base is, of 1, if you convert this to exponential form, what we're saying is a to some power has to equal 1. Well, a to what power equals 1? A to any power, anytime x is 0, you get 1. Anything to the 0 power is 1, and so anytime you take the log of 1, you get 0. So the log of 1, 0. Got to know it with or without a calculator. Log of a, base a. So a to what power, base a to what power over here equals a? Well, a to the first power equals a. And so if you take the log base 10 of 10, or the common log of 10, you get 1. We should be pretty familiar with that. And so those are very huge things that you should learn. Without a calculator, find the value of this. Log base 3 of 81. So with a calculator, right, we would use the change of base, log of 81 divided by log of 3. Without a calculator, I stick an x over here just to make it easier and change it to exponential form. And think, okay, 3 to what power of x is 81? So then this has got to be equal to 4. Because 3 to the 4th power is 81. All right, over here. 4 to what power is 0.25? Or in other words, 4 to what power is 1/4? Might be easier. And so how do we get the 4 to flip over and get 1/4? That's those negative exponents, right? And so if x is -1, that's what makes this flip over. Equals x, 0.5. 0.5 to what power is 4? Or in other words, 1/2 to what power is 4? Well, if this was a 2, 2 squared would be 4. And so it's related to 2. However, we need it to flip over so that it actually becomes 4, and so we're going to use that negative exponent again, because if you do 1/2 to the negative, that becomes 2 to whatever power you have, so it'll be 2 to the 2nd equals 4. So it's -2. Evaluate again. So we get 2 to what power of x? And again, what we're doing is we're taking it from log form to exponential. 2 to what power is -4? If I multiply 2 by -2, I get 4. But there's no power I can raise it to get -4. And so this, there's no solution. It's undefined. What we'll find is that you can't take the log of a negative, and actually we just found it. If you take the log of a negative number, log of -5, non-real answer, not possible. So, by definition, logs are the inverses of exponential functions. What we mean by that? +3 and -3 are inverses. Because if you add 3 to something and then subtract 3 from something, you'll get back to exactly what you started with. Or if you multiply by 5 and then divide by 5, you'll get right back to where you started from. Those are inverses. So if we take the log base b after we raise it to a power, this is going to undo the exponent. The log undoes the exponential part, and you just get what you started with. If you raise b to a power and then take the log. Or, if you take the log base b, these two have to match up, by the way. Base b, base b, base b, base b. If you take the log base b of x and then exponentiate b to that log, you just get x, because they are the exact inverse of each other. So, how do we apply this? 10 to the log of 7. Well, log we know is the common log, and so that base and that base are the same, just like what we had over here. And so this is going to be equal to 7. This is not quite the same, and so we have to adjust it, because this is base 7, but this is base 49. But we can adjust our 49 so that it's 7 squared, and so then it's log base 7 of 7, and we can multiply those exponents. We're raising a power to a power, so that's to the 2x. And so finally, base 7, and so this is equal to 2x. All right, inverse function. Find the inverse function. So the first step in finding an inverse function was always to swap the x and the y. Learned that when we talked about inverse functions. And then what we did was we solved again for y. So let's first get rid of the 7. So we get x minus 7 equals the natural log of y minus 2. So now we have the natural log, which, if you have to remember, has a base of e. And so now we're going to change it from the log form to the exponential form. What I mean by that, just like we took the log form here and changed it to 3 to the power equals 81. Now our log is on the opposite side, but so we're going to take e and raise it to the power that's over here, to the x minus 7. And that's going to be equal to what's inside of the log, y minus 2. Almost have it solved for y. If we move the 2 over, we have e to the x minus 7 plus 2. And that equals y. And rather than moving the y to the other side, that's our inverse function. So we swapped the x and the y, realized that the natural log was base e, and then changed it to exponential form from log form. Remember how I said that was going to be huge? That's what I'm talking about.